solve maximum product of two digits together. I haven't tried solve or code this problem before, so I think we can just do it live together now. The problem statement is you receive one integer, for example 124. Find the maximum products from multiplying two digits inside this number together. For example, in this one we have digit number 1, digit number 2, digit number 4. The output would be 8, because 4 and 2 lead to the maximum possible products. When I first see this problem, the first thing that come to my mind is we should try to iterate to extract each of the digit out. And from there, in order to get the maximum product, we probably want to pick the two digits that has the largest number, because two largest number usually multiply together and lead to the largest product as well. And to make it efficient, we can use something similar to counting table to count the frequency of each number, so that you don't need to maintain, itemize like list of n number. You don't need to do you don't need to use sorting function. You don't need to do quick sort. You just put everything in the counting table, and then we iterate from number 9, number 8, number 7 downward. Because the higher the number we found from this frequency table, it would most likely lead to maximum products. Let me show you how to do the coding. So the first part, I would say that extract all the digits out, right? So that would usually the code will look similar to this. So let's see, each digit will look like this in mod 10. For example, 124, when you mod 10, you get number 4, which is the last digit. And then you will remove this digit out by divide the entire number by 10 and round down. For example, 124 divided by 10, you will get 12. So that's how you decouple between last digit and the rest of the number. So this one would be last digit, and then this one basically to remove that digit out. We need to make sure we round out as well. I use JavaScript, so I will use math.floor. And then we want to do the counting table, right? So let's say that it's a frequency table, which is array size 10. Size 10 means the index will be from 0 to 9. So basically it will look like this. And then from every digit we will count their frequency upward. The target here is when your input is equal to 124, we want the counting table to look something like this. This is just to visualize, so it will look like number 1 we found 1 time, number 2 we found 1 time, number 4 we found 1 time. And the reason is because we keep mod 10 and then keep removing it and keep doing it. So you will get this digit breakdown by key, number 1, number 2, and number 4 each one time. But if your input is 1, 2, 4, 4, then you will mod and receive number 4 twice. In this case, your frequency will look like this. That's basically our target. And from there, we will loop from the largest digit to the smallest one to find the largest two number. We try to get the two frequency number that we found. So let's do it. So it will look like this. Start from 9, that are the largest possible digit from this frequency table array, right? So from there you loop to number 0. Keep in mind that when you loop to number 0, don't forget to make it inclusion, to be greater than equal. Then we will do it, and then we will need to create the placeholder for our output. And since we're going to multiply it together, right, it will look something like this. If frequency I greater than 0, then we will try to include this digit into our final product, right? So this would be multiply I. And to make sure that it keep compound up, let's start with 1. Yeah, basically 1 multiply any number equal to that number, right? So you get something like this. We probably also want to make sure one is we grab only 2 number exactly. So let's do like count how many number we use. If we found the number, then we combine that number to our final output, and then we do the counter. And then if the counter like already if we already find 2 number, we start with 0, and if we keep counting and reach number 2, then we will just return the output. We don't need this anymore. So in this case, this should be y actually. Y frequency I greater than 0, then we keep included in, and then we make sure we decrease it. Yeah, so that like let's say that if it look like this, in this way we make sure that we use the greater number only 1 time. After that, this one number will change to 0, and then it will loop down to the next number. But if we can do this here, if count greater or equal than 2, but most likely it will reach number 2 first. We can even do this. Yeah, quite confident it will reach number 2 first. Then we return output here. Now these are the cases where the input has less than 2 digits, right? Yeah, because there are cases where you try to find every number, but the counting never reach this condition. Then it means that like it could not find any solution. However, our constraint of the input is always greater or equal than 10, right? So worst case, let's try each case is 10. If it's 10, let's see, the frequency array is, the last digit of 10 would be 0. Yeah, so it would be something like this. And then after 10 divide 10 equal to 1, it will keep repeat doing this. Then we will get this one as what we expect to. And then if the input is 10, this is our frequency table. Then we loop from 9 to 0. All the frequency from 9 to 8 are 0, so it won't hit in here. And then the first time it reached number 1, it hit into this for loop and compile output to become number 1. And then we'll decrease this frequency, right? Yeah, and then we keep doing that. Okay, I think that's all. So let me see if there are other edge cases. I would say, I don't know if it will give me this kind of input. I hope not. Yeah, because this is more like integer input, right? So it will give me, it cannot give me single digit as well because it requires that. So we can do like let's say this one, you will find so many 0 number occurrence show up, which is 4 frequency, and number 1 come 2, and then most likely you get enough number and reach count to number 2 before you get to 0. Therefore this would return 1, which is also correct. This one our code should return 1. This one our code should return 0. This one should return 12. Alright, let's run it. Time limit exceed. I think it's stuck in the loop somewhere. Oh, okay. I put the my mistake. I put the while loop in the wrong place. I'm missing one line. So let's try one more time. There you go. I think we got passed in all 3 example cases. Let's submit to the real one. And we got our final answer here. All right. Thanks a lot, everyone. Oh, by the way, for the time complexity for this algorithm, this for loop it takes O log n, but keep in mind that these are the log base 10. The main reason is because we make our input 10 times smaller in each iteration, so it's actually log 10, log n in the base of 10. And then for this loop is the constant time, so this one will be O constant, and to be specific we loop 10 times always. And to make this algorithm work, we need the memory with size 10 as well. So this one memory size 10. This one will be time. Yeah, and time complexity log n plus static, log n is larger in terms of the complexity trend. So therefore this will be our big O. Alright, thanks a lot everyone.